All right, so we want to do graphics to paint tic-tac-toe boards and stuff. So there's a class called Graphics, surprise, that comes with a bunch of methods for doing things like drawing lines, filling in rectangles, drawing ovals, drawing text, things like that, on a J-frame or a panel or some sort of graphical component. Okay, and you can look up the documentation for some of these things. So, for example, if we say, graphics G, we can say G.fillRectangle, and we can put in an X location, a Y location, and a width and a height, and it should fill in a rectangle for us, right? But it's not going to do anything like that for us, because if I just say graphics G equals new graphics, I have a graphics object, but it's not connected to my display. It's not connected to my Jpanel or my J-frame or anything else in my program. It's just a graphics object, and even though it has a method called fillRectangle, I can't expect it to actually fill a rectangle in on my display. Okay, we've got to get some way to connect this graphics object to an actual component that we're looking at. So let's start a new project. So this is going to be bgraph. And I'm just going to make a J-frame as our outside wrapper. And so here's the design window. This is our J-frame that we just constructed. And you notice that inside the J-frame there's a content pane. It's this smaller window inside here. Okay, and it comes from class Jpanel. So let's take a look at the Jpanel class. And it says a bunch of stuff. We don't really have to worry too much about it. It's really, a Jpanel is a component, which is a container, which is a component, which is an object, right? So whatever the heck that means, it's this thing that we can drop buttons and text boxes and things like that into, okay? It's also a thing that we can do drawing on top of if we like. And how do I know that? Because if we look at the Jpanel and we come down to the methods, there's a method inside the J component called paint. And if you look at the paint method, it's a method that takes an argument, which is a graphics object. And if we look at what the graphics class is, that's this class that has things like fillRectangle, right here. So the theory is that a Jpanel has a paint method, and that's what's actually causing this Jpanel to appear when we run our Java code. Now, the Jpanel looks kind of boring, but there's actually some stuff going on, because, for example, in this Jpanel, I can change the background color to be black. And now when I run this, the inside of that J-frame, the panel, is actually black. Something had to paint those pixels black in order to make that happen. And I'm actually going to make it bright. I'll make it light gray. So there's some painting happening in here, okay? But our goal is to make a little rectangle somewhere inside this display. And we know how to do that. We just use the fillRectangle method on a graphics object. And there's already a graphics object ready for us to go. Right? It's the argument to this paint method. All right, so there's a piece we're missing here. So let's go back to our JFrame and look at the declaration of JFrame. So my main class is called main, and it says public class main extends JFrame. So we've talked about the extends word a little bit. Extends basically says JFrame is an already existing class. It's got fields, it's got methods, it's got a whole bunch of stuff. I want all that stuff for myself too. I want all that stuff to be a part of this class main that I'm writing without having to write it myself. So it inherits all the stuff that's inside JFrame, and now that's a part of main. Okay, this is why when I construct a frame, which is an object of type main, it has a setVisible method. Right? Nowhere in my description of this class main did I describe what the setVisible method is. I didn't write that code, but it exists, and it exists because it exists inside a JFrame. So it inherited from the JFrame class this setVisible method. And in fact, my frame object, which is an object of type main, has all of these methods available. I didn't write all of this. Right? Our class definition is like 50 lines of code. But we can run all of these methods from a main object because it inherited all of that from the JFrame. Okay, so inheritance is a really powerful concept. It's how we get code reuse. It's how we can say, you've got a really cool class, I want that too. And now we just make our class and we say, give me everything that's in that class, and then we just add some other stuff to it. What?
I'll have what he's having.
I'll have what he's having. All right, well, we can extend this to the Jpanel. So we know there's a thing called a Jpanel. We just looked at the documentation for it a while ago. This content pane, the thing inside the JFrame, is a Jpanel. So let's make a picture. Here's our JFrame. It's got these little things in the top. It's got some picture over here. But this is not a JFrame, right? This is an object of type main. But it's an extension of a JFrame. So it's effectively a JFrame. All right, this stuff in here, this is a Jpanel. And it's a Jpanel called content pane. And this Jpanel has a paint method available to it, but we would like that paint method to do something different. We'd like it to draw a rectangle for us. We cannot change the paint method in this Jpanel class. Right? We don't own this class. It's a class that's part of Swing. But we can do the next best thing. We can make a new class which is kind of a clone of a Jpanel, but which we own and we can make changes to. In particular, we can change the paint method. So we're going to do the following. We're going to make a new class, and we're going to call this my super cool panel. And I'm going to say extends Jpanel. And I'll need to import things along the way, so there's my Jpanel. All right, I've defined a new class, my super cool panel. And so down here, instead of saying the content pane is a Jpanel, I'm going to say it's a my super cool panel. And down here, when I construct, instead of constructing a Jpanel, I'm going to construct a my super cool panel. And if I run this, it's going to do exactly what it did before. But I'm not using a Jpanel anymore in this code. right? I'm using my own version of a panel. Happens to be exactly the same as Jpanel. But it's my class, my super cool panel. Here's the description of it. Now I didn't write and say again? Wrote the whole thing myself. All right, well, our reason for doing this is we want to change the paint method. Okay, so here's what I'm going to do. I'm going to write my own version of public void paint that takes a graphics argument. And all our paint method is going to do is print out the message, "Hi, I'm inside paint right now." Okay. So I run this, and I got 4 messages saying, "Hi, I'm inside paint right now." So something called this paint method 4 times, just in running my code and making this frame visible because it has a panel inside. And if I take this panel and I make it bigger, my paint method keeps getting called. Why? Because that's what the paint method does. It draws this component, the Jpanel in this case, or the MySuperCool panel in this case. And when you resize a window, I'm changing the J-frame. The system knows that the J-frame contains this MySuperCool panel, and so it may need to be redrawn. And so it will call the paint method, and that's what's generating this message down here. All right, so let's do something more useful. Let's make a rectangle. So G is a graphics object that was passed to our paint method. We're going to say fill rectangle. We're going to make a 100 by 200 rectangle situated at position 50, 50. There's our rectangle. And if I shrink my window and that rectangle goes away, and then I make my window bigger again, it reappears. The reason it reappears is not because it's always there, it's because when I resize, the system is calling this paint method, and it's saying fill this rectangle. So we have some hope of being able to do graphics, right? We can make shapes appear. So we can draw an oval, and there's a circle. It's a circle that's actually an ellipse. Or an ellipse that's a circle. All right, so this is the way that we're going to draw things on our window. We're going to override the Jpanel class with our own class. Okay, so we'll make a class that extends Jpanel, and we'll write our own version of the paint method. Now let me see if I can break this really quickly. Let's throw some buttons on here. Well, let's put a layout. And you notice there's a circle sitting here in my design window. The code actually knows that the paint method is going to draw a circle there, and so it's showing it to me even though I'm in my design window. It's kind of giving me a really good preview of what's going to happen.
Is there a way to draw like a prettier circle or like a more
You don't think my circle's pretty?
smooth, non-pixelated circle?
Possibly. We can control aliasing and stuff to some degree. So I'm placing buttons on here, right? And they don't seem to be appearing. And when I run my code, I don't seem to have my buttons, but they're there, right? And if I resize, they might disappear or reappear.
Another fun game to play.
Another fun game.
It's like Minesweeper and stuff.
Yeah,
Minus explosion.
it's ultimate battleship.
Less death, more awesome.
Yeah. All right. So something's not quite right here. Okay. There's buttons that should be visible on my panel, but they're not appearing. Why are they not appearing? Because I never painted them. Yeah, I've got the paint method now, right? This is the whole paint method. When the panel needs to be drawn, this is the code that executes. What does it say to do? Draw an oval. That's it. Does it say draw a button? No. Does it say, you know, draw the outline or set the border or set the background? No, it doesn't do any of that stuff. All it does is draw an oval. And there's a whole lot more we want to do. For example, we want to paint these buttons, and we want to fill in the text, and we want to set the color and the outline and stuff like that. That was happening before when we had a Jpanel, because Jpanel's paint method does all of that stuff. Well, we want to make a rectangle, so we're making our own paint method, but in doing that, we've taken Jpanel's paint method out of the system. We'd really like to get that back. Here's what we really want. We want Jpanel's paint method to do its thing, and then we want to do our thing. Okay? We want both worlds. You what?
Can you extend the method?
Yeah, like our paint equal or extends paint.
Basically, that's what we're going to do. But there's a really subtle way to do it. So you know about the this keyword, right? This refers to me. Okay, there's another keyword, super, which refers to the class that you extended. Okay, so the terminology is that my super cool panel is a subclass of Jpanel. Jpanel is the superclass of my super cool panel. So I can say, let's call the superclass's paint method. Let's pass it that G object. And super.paint is the paint method from Jpanel, right? The Jpanel that I extended. So this will call the original paint method with the same argument G, and then it'll go ahead and draw an oval. So now if I run this, I've got my buttons, I've got my text field, and that should all be nice and stable as we move around. And if I go back to my design window, those may have appeared. Nope, they didn't appear. That's a bug.
Does it matter what order? Can you throw that at the bottom?
I think that's one of the few things that the order is critical.
Oh, so it needs to be at the top.
Right? Because what does super paint do? Well, it erases the component, gives you a blank slate, and then it draws the buttons, so it erased my oval. All right, so that's just a trick we need to remember. And there's paint and there's paint component, and everything I'm saying works for paint component also. And paint component is really what you're supposed to use with swing, but I'm using paint because, I don't know, because that's what I'm using. It's less typing. But there's a method called paint component, and that's technically what we should be overriding, but paint works fine. All right, so we can do some painting. So let's tie this into something. Let's make a circle that follows your mouse around. Okay, so we'll make like our own mouse pointer. So anywhere you move the mouse, I want to draw the circle right there. Well, I need to figure out mouse positions. So here's our Jpanel. We can say add an event handler, mouse motion, mouse moved. And so this is, nope, that's not what I wanted to do. I accidentally did that on top of my text field. All right, so add event handler, mouse motion, mouse moved. All right, so I'm adding a mouse motion listener to my content pane. Okay, that's my super cool panel. And down here is the code that's going to run whenever the mouse changes position. So there's a getX method and a getY method for this mouse event E, which will give me the X and Y coordinates. So I can do something like this. So I can get the X and Y coordinates, and what I want to do is draw a circle at those X and Y coordinates. But I can't do that here. I can't draw a circle unless I have that graphics object, G. And I don't have access to that inside this mouse moved method. The only place I have access to that graphics object is down here in the paint method of my super cool panel. So this is stateful. What we can do is when you move the mouse, we can record what the XY position is, and we can save that somewhere so that the next time paint gets executed, it draws the mouse at those XY positions. All right, so how are we going to do that? Let's make some variables in here. So there's some last X and last Y variables. And I'm going to right click on here, and I'm going to say something really cool. I'm going to say source generate setters and getters. And I'm going to make setters and getters for last X and last Y. And so it's written some code for me. What?
Yeah, you missed the Y.
Oh, bummer.
You're right clicking on the variable, is that what you're doing?
Yeah. Where was it? Source. Generate getters and setters. Hooey. Okay. We'll do last Y.
Yeah,
Did I do it?
one,
Oh,
not
okay.
the other.
Got it. Okay. Oh yeah. So there's options for, do you want to do like getter getter setter setter, or getter setter getter setter, and all this kind of stuff. All right. So we've got in particular a set last Y and a set last X method. Okay. And down here in our paint method, instead of painting at 50-50, we'll paint it last X last Y. Bless you. So down here we get the XY positions of the mouse, and what do? We say content pane dot set last X, content pant. And then content pane set last Y, last Y. So we save those, and now when we paint, we're going to paint the mouse at that position. And this will almost work. So I can come in here, but it should be drawing a rectangle right here, and it's not. But if I take this window and move it off screen, or maybe if I resize it, right, it draws my circle for me. And if I move my mouse over here and then I resize, or move it there we go. So there's one more piece, and then we'll have the full story. We're setting things up. We're getting a mouse event. We're saving the X and Y position inside these variables. And when the paint method is called on the panel, it's going to draw a circle at that XY position. But when is this paint method going to be called? It's going to be called when it gets resized or when another window comes on top of it or something happens and it feels like it needs to repaint this. And until that paint method gets called, we don't see a change. So what we'd really like to do is in here, after we update the X and Y position, we'd like to have that paint method run. But we can't just call the paint method because we don't have this graphics object. But we can do the next best thing. We can call repaint.
Paint.
Yeah. So we can call the repaint method. Okay, so what is repaint? Repaint issues a request to say, please paint this object for me. It doesn't call paint right away, it schedules it basically. It says something in the system wants this thing to be repainted. Specifically for this reason, because we've made a change to what the paint method's gonna do. And at some appropriate time, the system will call paint. It may not happen right away. I mean, you won't notice a delay, but there may be other things that have to happen first. But eventually, the system will call paint for us. So now, if we run this, we've got a circle that follows our mouse around until we're on a button, because now that mouse movement event's being captured by the button, not by the content pane. So when we pop out of it and we're back on the content pane, we start picking it up again.
So how would you make it to where it's more centered
Yeah.
instead of?
Oh, so if you look at the draw circle, the XY coordinate you give is the upper left corner. So add half the radius in each direction,
Okay.
right? And that will get you back there.
So you would add that to the last X and last Y.
Yeah, so, or we could put it down here, right? So our radius, our radii are 50. So I think we can just do plus 25.
And minus 25.
And probably plus 25.
Oh.
That was one possibility.
It's a graph, so X you have to be an opposite graph.
Yeah, so we're trying to move down and to the right. So we've got to adjust the coordinates back. So there we go.
And then you want to play with it to get it back.
Yeah. All right, so that's a lot of parts and pieces, but that's the same set of parts and pieces you're going to use every time you do this. Okay, so let's summarize. So extend Jpanel. Write a paint method. Make sure your paint method calls super.paint. Right, with whatever graphics object. And then when some action occurs, set up data for paint. Save your XY position or whatever makes sense to be doing, and then call repaint. That's the shorter version of everything we just did.
So are we going to be pretty much drawing lines for the
Draw lines for the field, draw circles or X's for the marks.
And then when you're printing a circle or an X, you need to kind of know what the coordinates are for each area.
Yeah. We'll talk about dissecting coordinates shortly. Yeah.
So you could do the same thing with the old Jpanel and make it follow the mouse around it? Or would that be different?
What do you mean with the old Jpanel?
Like make the whole window follow the user's mouse.
Oh.
If they go outside the window, it chases the...
Yeah, you could do other things with this also that don't necessarily need the paint method and the graphics class and such. You can pick up mouse events and reposition the whole frame if you want. So your mouse is always like, you know, in the upper left corner or something.
Oh, yeah.
Yeah. All right. Let's talk briefly about color. So, back on our beautiful CRT picture, right? I said imagine 3 guns, red, green, and blue, that can light up pixels in one of 3 different colors, and by changing the intensity and putting pixels next to each other, you can blend those colors together. We use the same model, okay? And while we're here, right, so this is X, this is Y, 0, 0's in the upper left. Okay, and the pixels that you're referring when you pass an XY to draw a rectangle or fill oval or whatever, right, are relative to this coordinate system. So color models, we think of 3 color sources, red, green, and blue. Right, so this is the RGB you always hear about. And typically, we use 8 bits to specify the intensity of each of these colors. So the colors can go anywhere from 0 to 255. And taken together, we have a total of 24 bits of color information. So 24 bits, 16 times 2 to the 20th, 16 million colors. Okay, typical model. And if you were to set all of these colors to 0, it means there's no red, there's no green, there's no blue, that's black. Okay, it's basically an unlit pixel. If you set them all to 255, that's going to come out white. If you set it to 128, 0, 0, it's going to come out as kind of a halfway bright red. If you do 255, 0, 255, it's full intensity red and blue, that's a bright purple. Okay, and so on. So you can mix these colors by changing this 8-bit intensity for each of these 3 components. And so there's a class called color, and color can be constructed with 8-bit values for red, green, and blue. Okay, so integers from 0 to 255. Or you can construct it with floating point numbers from 0 to 1, no intensity to full intensity. Or you can make a single 24-bit integer where the first 8 bits are red, the next 8 are green, the next 8 are blue. And pass that as a single argument. And there's other options as well. And there's some predefined values for you, like black and blue and dark gray and green and so on. And those are all colors. So those are preset up for you. And there's methods like brighter and darker. If you have a color and you call the darker method, it will return a slightly darker version of that color.
Can you go back up? You give it an int for red, green, blue, and it has to be below 0 to 25. What happens if it goes higher than that? Is there
I don't know. I don't know what it will do in that case.
Just thinking if you made the x, r is the x coordinate value, and b was the y, and then the last one was then added together. But what would happen if they were both 255?
I'm thinking it will truncate it, but we could truncate it ourselves.
Oh, okay.
So, but let's try that, okay? So we can construct colors, and in the graphics object, in the graphics class, there's a method called setColor. And setColor sets the current context color to whatever you specify. It doesn't change the color of anything on the screen, it changes the color of whatever gets drawn next. Okay. But let's mess with color. So before we draw the oval, let's do g.setColor. And we'll just make a new color, 25500. So that's going to be red. Import the color class. So if we run this, we've got a red circle following us around. So let's do what you suggested. Let's set the color based on your XY positions. and I'll truncate it, but we can try without truncating next. But now we're just going to modulate the red and green components based on X and Y position. I'll make a big window. So, well, that's not too exciting.
Can you make it thicker?
So let's fill it. All right, so now we got a new video game. Bang.
My vision is
Right, so pretty. Yeah, totally.
A bunch of this stuff falling from the top and bouncing around.
Yeah. Oh, totally. Yeah. So I'm just curious if it'll actually give us an exception. Or if it will truncate silently.
Oh.
That's
Oh.
not good.
Yeah. So we're getting tons of exceptions in here.
Video game Friday
So
night.
look at what you did, man.
This is why we can't have these things.
Use the yellow circle. If you can
All right.
circle the other side of the screen, I'll give you $100.
There you go.
Yeah.
All right, so we can work with color pretty easily, right? It's really just a set color, and you could put in the name of a color like color.gray, or you can construct a color with a new color with either fixed numbers or change it in some way, and so on and so forth. That's enough to get you all the painting that you need to do, right? We can draw lines. That means you can draw the winter mark. You can draw X's. You can use draw oval to draw O's, and that's pretty much all you need. If you want to graphically display messages, right, there's draw string method, and you can give it a string and X and Y positions.
Comic Sans.
Didn't like my draw string. Draw string.
You have to do the string
Oh,
first.
string goes first. Okay.
Who's laughing now?
Yeah, right. Who's the pathetic earthling?
Yeah.
All right, so there we go. That's pretty cool. So we can control the font as well, right? So we can set the color. We can also set the font. And the font is a whole class in itself.
You can translate it.
And you can construct a font with various ways. You can set things like italicized and so on and so forth.
A new graphic for every, like, for each like circle and X. Like if you have graphic G, you'd need multiple graphics.
So you can do this with a single panel, right? So this whole thing is just a single My Super panel, right? And it's got one paint method. And inside that paint method, you draw the board, you draw the X's, you draw the O's, you draw the winter mark, you draw whatever else you want to draw, right?
And those are all different graphic objects, though.
It's all inside that one paint method, so it's working with that single G that was passed to you
okay.
here, right? So draw 4 lines to make the playing field, and then figure out where you need to draw X's and O's and do draws for that, and so on. And that's all inside Paint.
So you're using G, but you would call different. Like if you want another oval, you would do another G dot fill oval.
Yeah, with different XY
Okay.
coordinates.
For drawing a line,
Could you make this circle where when you drag it, it keeps the circle, like you're...
Yes, and there's a cheap way that sometimes works to do that, and then there's the right way to do it. So the cheap way is sometimes if you get rid of the superclass, it won't clear the display for you, and it'll let you do that. And I don't think that was working with this version when I tried this the other day. But it used to be, oh, there we go. Okay, cool. So, yeah. But that's not really the right way to do it.
That's cool.
Yeah.
Looks like an old screen set.
Touch is black.
Stay away, Jack.
Enjoy
Yeah.
painting, Mr. Macias.
But it's not the right way because, right, when I resize, it all goes away. This is called Pathetic Earthling.
Yeah.
There was a time when you could do this and you could like sell it for like, you know, $100 because nobody had any idea how the world you did this, right? You know, just like, but maybe we're still there, I don't know.
So that's actually,
Selling
you could
glitch.
paint the dot in the middle of a canvas and sell it for probably millions of
You could
dollars.
sell a 1024 by 1024 image for $1 million. Sell each pixel for $1. Do you remember that website?
Oh, yeah.
Yeah, that was like brilliant. So you can do this, but it's not the right way to do it, right? It's just kind of a trick that works because we're forgetting to do something we really should do, which is have the superclasses paint method.
So we should have a line say, like when you lose, have the computer draw a line that says pop.
Yeah, totally. But if you wanted to do, you know, an etch-a-sketch thing where it actually followed you around, you need to basically save the position of each thing that you want to draw. So make yourself a big array or a linked list or something, or a queue probably. And each time that you come into here, save the current XY and draw everything that you've saved. And if you make a queue with 1,000 entries, right, it'll draw the last 1,000 positions. And so now you've got like the snake game where it'll kind of follow you around, but the older pixels will disappear eventually. And
Have your shape follow your cursor around so when you click it looks like you're dropping them.
yes, you could. And you could take the older events and you could actually just turn down the intensity so that the tail just kind of like fizzles out as you move around. So this is where I say, right, you can take this and you can spend as much time and go as deep in as many different directions as you want. And it's all time well spent, right? It's going to help you understand the graphics class and painting and things like that, certainly. But also, you know, if you want to do something like that, you're going to suddenly have to implement a queue inside Java. Well, maybe you've never done that, but you've done it in C, right? And if you spend an hour implementing a queue in Java, well, now you know more about queues than you did before. And that's good. That's going to help you because you'll be using queues forever. And, right, so I mean, you can really kind of like have a lot of fun with this. This is why I almost failed out of school, because this is what I spent all my time doing. And my physics class was like economics, all that
The
stuff.
best part is every time someone says, "Hey, can you do this?" the answer has been yes almost every time.
Yeah. All right, so that's so that gets you color. You got fonts. You can draw things. We've got the paint method. We've got superclasses, extensions. We've covered like 1 billion topics today already, and we've still got time left. So this is good stuff.
Could you quickly go over how to export and import projects?
Yes.
Oh yeah.
So let's export this. So you've only got one project open at a time, right? So I'm going to right-click on my project, bgraph. I'm going to say Export, and I'm going to come up here under General, and I'm going to say Archive File. Say Next. These should all be selected for you. Put in an archive name, and then just say Finish.
Can you hit it one more time for the note takers?
Start off with right-click on your project. Export, General, Archive File. And then make sure that all 3 boxes are checked. Put in an archive file name down here where it says to archive file. And you can browse to a path if you want, and then just say Finish. And that gives you the zip file you want to upload to Canvas. Now, when you want to import it, close out your projects. Say File, Import. And this time under General, say Existing Projects into Workspace. That's the trickiest part. So don't do archive file to import. Do Existing Projects into Workspace. And then on the next screen, say Select Archive File. And browse to your file. And normally this will let you finish, except I've already got a B graph and it's trying to import a B graph, so it's giving me a warning. But move this out of the way, right? Refactor it. Open it up and refactor it. So refactor, rename, let's call it B graph 2. And then I'm going to close that. Now if we do the same thing, File, Import, Existing Project into Workspace, select Archive File, Test Export. It'll tell me it's going to import bgraph. I can say Finish. There's my imported project. And go to that, make sure it still runs. You're good to go.
Thank you for asking that, because that was something
Yeah.
I was thinking about
Thank you.
earlier, and then I didn't think about asking.
Yay.
Last period, then my computer died and I forgot.
Okay. Yeah.
So the methods that we have listed on the Pt2 thing,
Mm-hmm.
you can add more. If
Absolutely.
Okay.
You probably want to add more.
Alright.
Yeah. But take a look at the sample usage. Okay, this is what I'm going to do. So you definitely want your main class to be called index utility. You want that thing to have a build index method that returns a word list, and you want word list to have a print method. Okay, if you don't have those, my test code won't work, and then I'm going to take a really close look at your code. But these others, even though I recommend calling them add word and print and so on, right, or add and add word and so on, right, those aren't exposed to the outside world. So, yeah.
So if we can plug in that test code and it works, then
It's a pretty good first test.
okay.
And then just test it on some really big files and lots of files and make sure that like things are in different orders and words appear twice and so on.
How?
You want words to appear multiple times?
Well, if words appear multiple times in your input, right, you should collect them together,
Oh, okay.
right? So that's just something you want to test. But this is a program that probably, if, you know, a sort of basic test file like this, if it does the right thing, you're probably pretty good, right? Maybe it'll blow up on War and Peace or something, but it's not going to kind of halfway work. And then if I put the word elephant, it's going to blow up or something, right? It usually doesn't work that way.
How do you
So,
put the text of a file into your program through Eclipse?
so redirect standard in, and
Oh, do you already have it on the canvas?
yeah, I posted it, but I don't remember if it was an announcement. I'm starting to put things in discussions, but I think I put it in an announcement.
Oh, yeah, not this, but then again, that was.
Yeah, I need to get rid of all my debugging systems.
Could be Eclipse happiness.
Glad I didn't have to get rid of it.
Discussions.
Should I compare it to other processors? That's very quality. No, I get the character right there.
Oh, yeah.
That's what I was doing
But I
originally.
do see this. And it worked.
It's somewhere.
So you just do the whole 10 thing and current and then so you just
I don't
dump
know the correct way to create
until
a
next is null and then you create a new node. have the current point to yours and yours point to mine.
There you go. Let's try this one. All right, there you go.
You have to stand.
So system.set in, and then you can say new file input stream, new file, put in the name of a file. From that point on, when you read from system.in, it'll read from that file. And when you get to the end of the file, has next or has next line or any of those should return false. So if you just put that in the beginning, put this in the beginning of your main program, everything else is exactly the same. And your build index should work exactly the same because you're still reading from system.in. This is just kind of doing that input redirection, but it's doing it in code.
So do you do the try and catch only when you're dealing with input, or?
No, there's other places, but it's going to require it in here because the file input stream could fail if the file that you specify doesn't exist.
So why did we do try and catch when we were making a new scanner?
Because the scanner, if you construct it from a file, can also fail.
Oh, okay.
Right? So file itself won't fail. It'll just create a file object for that path name. But when you try to use that to create an input stream or a scanner or most other things, it has the potential to say, you know, IO exception.
When you're doing
And
from
Eclipse will tell you about those.
when you're doing a scanner from standard in though,
That you don't need to try catch.
so our program we don't need to try catch.
I don't think so. Eclipse will tell you if it needs it.
Oh well. Okay.
Yeah. But system.in is going to exist. So.
Mhm.
Did you have something?
Yeah, I was just gonna say if we just typed in something similar length to what you had in the test, like saying that if it worked on something that small, it would probably work in general. If we just type something in the standard in around that length, I think that would be
No, I would definitely test. You definitely want to make sure that you're so one advantage of a bigger file is just more test cases. It's not that the size of the file is critical, but you'd like to make sure, for example, that if the first word in your word list occurs more than once, that your code doesn't choke on that, because that's potentially an edge case, or the last word in your word list, right? Or if you get the same word 3 times in a row, does something weird happen, right? So a large set of input text will just sort of exercise more conditions than one that you might happen to type up.
But a large file would also be kind of hard to double check the edge cases, right?
Run it. Have a friend run it.
Okay. Yeah.
All right, so you're totally welcome to test each other's programs. You're totally welcome to compare test cases. Here's a file I found, I ran it, here's what I got for output. Run it on yours, see what you get. And if you get different things, right, you've got a good debugging exercise now. So, and if it's, you know, you should get exactly the same output basically, other than maybe like spaces and commas. But if you standardize that, you can just run the difference command on your output and you should see no differences. And it's a really quick sanity check, right? I mean, you do that with someone and you forgot to lowercase the words, it's going to jump right out at you. Your friend has lowercase words and yours is shouting at you, right? It's like, oh, I thought we were supposed to go to uppercase, right? Well, you just saved yourself like 2 points on your grade. And I'm fine with working with other people to test your code, do the quality assurance, debug, and check things like that. Sound good? All right, we're out of here. Hey, we'll see you next time. Oh, we did not get to doing icons on buttons, but the thing we were doing last time worked. I just had a bad icon file. So you can make a divide button and put it on there.